In Lesson 87, we'll be looking more at systems of equations, and then we'll also be studying about tests for functions. Now in Part A, this will be more about systems of equations. And remember in Lesson 79, we first learned about how to do these systems of equations where we had 4 unknowns. And remember what I said about those, as long as you have the same number of equations as you do unknown values, you can solve for that system of equations. And so what I want you to do in these practice problems, we'll do a couple of practice problems, is just solve for any unknown values that you have. So look at this system of equations. RATA equals RBTB. RA equals 20. So there's one value that we know. We know what RA is. RB equals 60. There's another value that we know. And then TA plus TB equals 20. Now we know the total of TA and TB, but we don't know what each individual one is. So that's what we'll be solving for, is TA and TB. Now really the only difference in this lesson and the one that you did in 79 on systems is that you'll have to rearrange one of these equations first before you substitute in. So remember what I said back when we did these, is you always substitute everything back into the equation that has the most variables in it. So we'll be substituting everything back into RATA equals RBTB. Let's go ahead and start. RA is 20, so we'll say 20 TA, and then RB is 60, so that'll be 60 TB. Now we need to rearrange TA plus TB. We need to solve it for either TA or TB. Not solve it, but set it equal to TA or TB. And then we can substitute it in to 20 TA equals 60 TB, and we'll end up with one equation and one unknown. It doesn't matter what we set it equal to. Let's just go ahead and set it equal to TA. So we'll have TA is equal to 20 minus TB, because we have to subtract TB from both sides. So let's take that and substitute it in for TA. And so we'll have 20 parentheses 20 minus TB is equal to 60 TB. Okay, so now we'll have 400 minus 20 TB is equal to 60 TB. And then we'll add 20 TB to both sides, and we'll have 400 is equal to 80 TB. And divide both sides by 80, or just think 80 times what equals 400? That would be 5. So TB is equal to 5. So let me write that up here. TB equals 5. If TB is 5, then directly above that we have what TA would be. 20 minus 5 is 15. So TA equals 15. The total of those two is 20, just like our original expression, TA plus TB equals 20. So that helps us know that we did the problem correctly. Let's do another one. Look at the system of equations first, and you can see there that we have R1 times T1 plus R2 T2 equals 12. T1 is 3, so that's a given value. T2 equals 1, there's another given value. R1 plus R2 equals 2. So we don't know what R1 and R2 are. We're going to be solving for those. So let's just go ahead and substitute what we do know into the equation with the most variables. That's the first one there. And so we'll have R1 times 3, or we could just say 3R1, and then plus R2 times 1, which would just be R2, equals 12. And then we know that R1 plus R2 is equal to 2, so let's just go ahead and rearrange that, and let's solve it for R2, because R2 is by itself in that equation we just made. That would be easier to substitute into a value just by itself like that. So R2 will equal 2 minus R1. And let's substitute that in now. 3R1 plus parentheses 2 minus R1 equals 12. Now let's go ahead and simplify on the left. So we'd have a 3R1 and a negative R1 would be 2 R1 plus 2 is equal to 12. Subtract 2 from both sides and we'd have 2R1 is equal to 10. And so R1 equals 5. Now, we can solve for R2 because we know what R1 is. Go back up to R2 equals 2 minus R1 and we'd have 2 minus 5. So R2 is equal to a negative 3. And so there's our pair of answers there. R1 is 5, R2 is negative 3. So you solve these systems of equations just like we did back in lesson 79. The one difference is one of those equations you may have to rearrange it now when you're doing these in the problem sets and on your test. So just be ready for that and know that if you have 4 equations with your 4 unknowns, you can solve that system of equations. You just may need to rearrange one of the equations first before you can substitute in and solve it. Remember, the goal of substitution is to end up with one equation and one unknown. Like on the right, this one that I'm circling. We ended up with that right there, one equation and one unknown, and then we're able to solve it. Part B of this lesson is about function tests. And let's just think about functions a little bit. We've talked about this before, that a function is an equation that you can graph on an xy axis. And we've talked about this standard form for an equation of a line, y equals mx plus b. A line is a function. We could just use the function symbol f of x equals mx plus b. And we know that we can take an equation like that, plot the xy pairs, and graph it on a Cartesian coordinate system, and it makes a pattern of a line. Now, there's other types of functions as well that aren't lines, like this, y equals x squared plus 2. Now, that's not an equation of a line. That's something called a parabola, and that one would actually look something like this. Now, this is the equation of a circle if you graphed a circle on an xy axis. And it has a radius of 2. And so if we graph that, it would look something like that. Notice though that I did not call that a function. I just said it was an equation for a circle. Y equals x squared plus 2, that's a function, because remember, to be defined as a function, every x value has one and only one y value. So no matter where we go on the x-axis and then up to the, a point on that parabola or that function, we will just get one and only one value for every x value. Now look at what happens with a circle though. If we go out to like x equals 1 and we go up, there's a point there, an xy pair that would be on that circle. There's another y value down here though, so that x value has 2 y values that it corresponds to or relates to. So that's really a relation. The equation for a circle is a relation. It's not a function. And so if you have a function that's graphed on an xy axis or an equation that's graphed on an xy axis, you can tell if it's a function or not by doing just a simple test. It's called a vertical line test. If you can draw a vertical line through it anywhere on that function and it crosses the function in more than one spot, then it is not a function. So those blue lines that I've drawn there, see on the circle, that blue line intersected in 2 spots. On the parabola on the left, it intersected just at one spot on the function. And so that is a function. The one on the right would be considered a relation. So just remember that. It's called the vertical line test. And if you have a function that's been graphed on an xy axis, if that vertical line can be drawn and it just passes through the function once, or the equation once, then it is a function. So look at practice problems C, D, and E. Use the vertical line test to tell me if those graphs are functions or not. So we're talking about the red lines or curves that I've drawn. Look at C. just do the vertical line test. Is there anywhere that you can draw a vertical line through that and it passes more than once through that curve? No, there isn't. So that is a function. So we'll just write f for function up there. Look at D. You can really easily tell that it's not a function because you can draw a line right through there. That would be considered a relation, but it's not a function. So we'll say NF for not a function. Now in E, we can draw a vertical line through right here, and it doesn't pass through anything. But that's okay. It just has to pass through one time somewhere. And so it does right there. There's nowhere where it passes through more than once, so that is a function. So if you are given the graph or the plot of an equation on an xy axis, you can tell if it's a function or not by doing that vertical line test. Okay, well that's all for lesson 87.